Up next, we will have Asiya Kimsky, Principal Solution Architect, MongoDB, to talk about replication in MongoDB. Ms. Kimchi, please.
You guys can hear me okay? Usually I pace a little. Unfortunately, I'll have to stay a little bit put. So, quick question. How many of you actually have used MongoDB? Ah, cool, like half of you. Of the other half, do you guys know what it is? Am I going to totally lose half of you if I don't do like a 60-second intro? All right, I'm going to do a 60-second intro because I'd hate for, some of you to miss out. So MongoDB, it's a database because, as DB indicates, it is a document database. So what's different about document databases versus traditional relational databases, which I'm sure you guys are familiar with, right? Yeah? Okay. Document databases, well, actually, how many of you are developers? Almost everybody? Pretty much a majority. So developers really like document databases because the data model, the way you see it in the application, maps very directly into a document database. Whereas when you try to store your data in relational, you have to normalize it into multiple tables, and then you have to do joins and blah, blah, blah. Anyway, if you have not tried MongoDB, there's drivers for over a dozen different languages, so you don't actually have to learn a new API or a new type of SQL. You just download the driver, connect to the database, and then you can persist the objects that you're working with in your code in the database. So it enables people to develop quite a bit faster. We're doing a session later this afternoon with a little bit of demo and hands-on, but that one's going to be more about sharding, which is essentially how to scale MongoDB. MongoDB scales horizontally, which means that if you develop an app and then it becomes really popular, let's say you deploy it in the cloud like Azure, then you just create more nodes and create more shards, and there you are, world famous. Now, what is replication? And what is replication in MongoDB? And how does it accomplish it is essentially the topic. So I'll talk a little bit about what the use case is for having replication. We'll go over some of the basics, how you interact with replication as a developer. The good news is it's not much different than interacting with a standalone database, and some operational things, and then some advanced concepts. Those of you who raised your hand that you've already worked with MongoDB, how many are actually running replica sets? Ooh, a few hands. Excellent. Those of you who are using MongoDB but are not using replica sets, hopefully by the end of this discussion you'll see A, that it's easy, B, that it's a really good idea, and C, that you should do it immediately after the session, okay, or during lunch break. All right, so we all want to have high availability. So what is high availability for our applications or for our database or for our data? So I don't know about you, but I have a lot of background dealing with databases. So I've worked with a lot of startups in my life, and I was always on the back end. Means I was the back end developer and I was in charge of the database. And to me, low availability is when your database goes down, your pager goes off. And wherever you are and whatever you're doing, you have to log on and you have to figure out, why the system's down, and you have to bring it back up because until you do, the app is down or the website is down. So high availability would be the opposite of that, right? So that if the site is down, in other words, if a database machine goes down, it automatically fails over to another copy of the data without anybody having to take manual intervention. Disaster recovery, well, that would be, let's say that you're deployed in your own data center, not somewhere in the cloud, but in your own data center, and there's some physical disaster. A storm knocks out the power, or somebody trips over the power cord and unplugs the rack. You lose your data, well, except that if you have it replicated in a different physical location, you actually have another instance of it. We all want to occasionally do maintenance on our servers. We need to upgrade the operating system, upgrade the version of, let's say, MongoDB that you're running. What really drives me crazy as an end user is when I log into a website, let's say my bank's website, and they have, oh, sorry, we're down for maintenance for the next 6 hours. And I'm like, but I want to pay my bills right now. But for some reason, they think that, Saturday night New York time is a perfect time to bring down the site every week. So replica sets allow you to do maintenance without actually subjecting your end users to any official downtime, which everybody likes. The goal of replication is also to be transparent, to the application and to the developer. In other words, you don't want to adopt some sort of high availability solution and then have to rewrite all of your code. That would be a bad thing. And of course, replication also gives you extra copies of your data. Now, what the extra copies are good for, we'll talk in a little bit of more detail, but obviously more is better than fewer, right? All right, so the basics of a replica set, and at least how it's implemented in MongoDB. So if you download and install MongoDB, you have a single standalone node. MongoD is the process you talk to. A replica set would be 3 of those nodes. And it could be 2, it could be 11, it could be 6. There's no convention that says that you must use exactly 3, but 3 turns out to be a really good number for a couple of reasons that I'll mention. One obviously would be a very non-resilient replica set, right? So one of them is the primary. So you don't really designate a role. Any one of the nodes in a replica set could be elected as a primary, and that's how a primary is selected. So Mongo is a single master architecture, which means that the writes always go to one node, the one that's the primary, and asynchronously, the data replicates to the other nodes. There's communication going on between the nodes, so every node in the replica set is aware of every other node. There is no single process outside of the replica set that needs to be looking at things, right? The nodes among themselves understand all of the rules that they're supposed to follow. So one of them is a primary, then the other 2 become secondaries. And as the primary receives data and writes it, the secondaries apply that data to themselves. So we'll call it replication. It's happening asynchronously. Now, what might that gain for you? So your primary node might crash, or it might become unavailable for some other reason. What happens is, due to the heartbeat and the fact that the connection from the primary to the secondary will disappear, the secondaries will notice, hey, there's no primary. And they all play by the exactly same rules. And those rules say, if there's no primary, we must elect a new primary. So they have an election. It's a consensus election. They have to agree. You can't have each one of them vote for themselves and be like, I'm a primary, and the other one's like, yeah, I'm the primary. No, so a new one has to be elected. There's a bunch of other rules that are followed. They're all very good rules to make sure that, minimize the chance of losing data in the transition. So let's say that node 2 became the new primary. Node 1 is now replicating from that. Here's a cool thing. When node 3 comes back up, so let's say it wasn't actually down, somebody just tripped over the network cable and accidentally unplugged it. So it was up, it just couldn't talk to anybody else in the world. When we finally plug that back in, it says, okay, I'm a member of a replica set. It finds its other members. It joins them and it says, what did I miss? Aha. It says node 2 is a primary. I'm this far behind, so I need to catch up. So it starts catching up and applying all the operations that it missed. And then when it's caught up, you're basically back to the exact same configuration you had at the beginning, primary and 2 secondaries. Different node is a primary now, that's okay. If you specifically want certain nodes to preferentially be primaries, there are settings to allow that, which means if node 3 has a preference to be a primary, then once he's caught up, he can call for a new election and say, hey guys, I have higher priority than you, so I'm going to call for an election and I want to be a primary again. So elections happen to make sure that there's only one primary at any one time. Now, the reason is that we don't actually ever want to create a situation when there's 2 primaries within the data set. The reason is that Mongo tries to maintain strong consistency, and if you had 2 primaries, I mean, imagine you had something as simple as a unique index. If you have two primaries and two writes come in at the same time and they both want to use the same username that's supposed to be unique, if both primaries accepted it, how do they resolve the conflict? Now, one of the people that was told you can have this username can no longer have it, right? So there are definite complications to being able to write to multiple places for the same data set, right? This isn't a right or wrong approach. There's simply different approaches. The way Mongo does this is by saying there can only be one primary, and therefore, you're guaranteed that you're going to get consistency and there won't be conflicts that you're going to have to resolve. So the way that the election assures that there can only be one primary is by requiring that you have more than a strict majority of the votes to become a new primary. So if you have 3 nodes in a replica set, and the majority is of the configured replica set, so you have 3 nodes, how many votes do you need to become a primary? It's not a hard question. 2. Number of people followed that? Excellent. So if you need 2 votes to become a primary, is it possible for 2 different nodes to become a primary at the same time? It's not, unless somebody is allowed to vote more than once, which they're not. Right, so there's a number of rules within the replica set semantics, and every node knows all the rules. This way they can essentially communicate across themselves, and they're not dependent on an external process to determine, who's going to be the primary, who's most qualified. One of the reasons, I'll tell you that the reason you always see 3 being demonstrated as the number of nodes, and sometimes you'll see 5, is if you had 4 nodes and you had a network partition such that 2 of them were on one side and 2 of them were on the other side. With 4 nodes, how many is a majority? How many does it take to be elected a primary? It's 3, because 2 is not a strict majority out of 4. You need greater than 50%. So since you need 3 votes, you have 2 nodes on one side of the partition, 2 nodes on the other side of the partition. Nobody can get 3 votes because there's no communication to allow 3 votes to agree on a new primary. So even number can place you in a situation where, even though every node is up, if the communication between them is limited, you can't elect a new primary. So odd numbers essentially mean that if there's a partition, there's going to be an extra guy on one side or the other side. So a little trivia about why the demos and the presentations always show 3. 3 make it kind of an easy concept. Takes 2 votes. If there's a network partition, 2 guys are on one side, 1 is on the other side. All right, so what are some other configuration options? If you've read about or heard about MongoDB replica sets, you know that there's a concept of an arbiter. So what's an arbiter? Well, let's say you need to have 4 copies of your data for some reason. Okay, I have 4 copies of my data. I could make them a replica set, except that I remember Asya saying that you shouldn't have an even number of votes, because if they get partitioned 2 and 2, there's going to be a problem to get an election to have a new primary elected. So you can add a 5th node, which is an arbiter, and it's a special member of a replica set that does not have to have any data. So it does not replicate data. It simply participates in elections. It's kind of like a tiebreaker, right? So if you only need 2 copies of your data, you have a primary and a secondary, but what about elections? So you add a 3rd one as an arbiter. You don't have to get more disk for more copies of your data. In fact, an arbiter is a very lightweight process. It could just run on some micro instance in the cloud somewhere. All right, so what are some of the operational considerations? Now, I know as developers, we frequently don't like to think about operational stuff, but it's kind of important because, that's what enables our applications to continue working. So we want to do upgrades with no downtime, right? And that's one operational thing that replica sets make very easy. So imagine you have these 3 nodes. What you do is you take one of the secondaries out of the set. So you bring the process down. Let's say the maintenance you need to do is, apply some patches on the OS and also upgrade MongoDB to the next release. When you're finished, you start up MongoDB backup, and you wait until it catches up for all the operations it missed. That worked great. So now we're going to take the next secondary out of the set, right? We're going to perform the maintenance. We're going to replace it back into the replica set, and we're going to wait until it's caught up. So now that we've essentially upgraded all of our secondaries, notice at no time did the application lose the ability to talk to the replica set as a whole. Now we can send a special command to a primary. So there's a command called step down. And that says, finish what you're doing and relinquish your primary role and let somebody else be primary. So we send the primary that command. One of the other two secondary nodes will now be elected as a new primary. Well, now your original primary is now a secondary, and you can repeat the upgrade steps with it. The failover, right, might be seconds, maybe less, and your application during that time, if it tries to do a write, it'll get a, hey, we're having an election right now, so it needs to have a retry logic, but most of the time applications would have that anyway to handle things like, intermittent network hiccups, for example, right? You have a retry, there you go, on the second try it worked, no downtime. Operationally, yes? Yeah, so generally, the question was, is replication still happening while you're doing the upgrade? So since you're upgrading one node at a time, the primary is accepting the writes, and they're replicating to the secondary that's still in the set. When you've finished upgrading a secondary and it rejoins the set, it catches up for the operations that it fell behind, right? And this is why the waiting until it's caught up is an important step, right? You wouldn't want to, bring down the next secondary while the first one was still catching up, because if your primary happens to fail then, which of course Murphy's law says the primary always fails, when you're doing maintenance on the secondary, which is why it's good to have two secondaries, right? You always have at least one up-to-date secondary that a failover can happen to. The design is? Yes, absolutely. Yeah, so if you're upgrading to like a major next version, yeah, we test replication to several versions back so that you can do a rolling upgrade to a new version. Otherwise, that would be kind of painful if you had to bring an entire cluster down, just to upgrade a version. Some other operational considerations. Let's say you have 3 replica nodes. If you put them in the same data center, obviously you're not going to be surprised to know that you lose high availability if that data center loses power, right? It goes without saying that if your nodes all run on VMs, do not run all the VMs on a single physical box. That's a bad idea. And we think it's funny, but sometimes people don't actually think about where the VM gets deployed to, right? Let's say their IT department, has a bunch of big servers, and no problem, we'll just virtualize all your nodes for you. Make sure to mention that they should be in different physical locations, let alone physical servers. So data center is prone to issues. Obviously, if two nodes fail, there's not enough nodes to have an election to have a new primary. So you say, you know what, I'm going to put my third node into a different data center. I'm going to call that my disaster recovery data center. So if I lose my primary data center, at least I have a copy of my data from which I can start up a new cluster. But the idea here is that physically you could never permanently lose your data since you have a copy of it elsewhere. A 3 data center configuration, 2 nodes in one data center, 2 nodes in another one, and a 5th one in some third location means you actually could lose an entire data center without losing any uptime, because losing a data center means you will still have 3 nodes that can elect a new primary. So probably the most resilient topology. What are some of the configuration options? Oh, by the way, if you've never configured a replica set, this is all it takes. This is JSON, so when you go to the shell, to the Mongo command line interpreter, it basically speaks JavaScript. So you define the configuration as a JSON document, and this one is going to have 5 members. When you've defined it, you just call the rs.initiate command, and rs stands for replica set. You have lots of rs commands. You can see what all they are by just doing rs.help, which is helpful. So here, we're going to give priority scores, and a highest priority score means that if all other things are equal and there's an election, the guy with the highest priority score will get elected as a primary. So maybe A and B are both, machines that are more centrally located relative to where the users are. So if A fails, you want B to become the primary. If B is not available, A would be the primary, and the other ones can't be primaries because you have other plans for them. So maybe B is in your secondary fallback data center. C, maybe you don't want C to be elected. Now, default priority is 1, because maybe you plan on running analytics against C. So one of the nice benefits of a replica set is you have extra copies of your data that you could read, and if you read some of them for different purposes than others, you can get much better performance. Your hidden node is one that no queries are going to be sent to by the driver, and that's probably the one that you're using to make backups from, right? All replica nodes have the exact same data, so to create a backup, you only need to back up any one of them. You designate a particular one for backups, operationally, that's nice. And just wanted to mention that there's an option called slave delay, which says apply replication with a fixed delay. And this is what we like to call insurance. Imagine that somebody didn't get enough sleep, let's say, and accidentally connects to the production server and drops some production database or production collection. I'm sure that never happened to you, but I'm sure you've all heard of somebody who had that happen to them. I know I have. And this allows you essentially to have a copy of your data that's a certain amount of time behind the current live data. Sort of if you catch the problem in that time interval, then you don't have to go back to a backup. You can just grab that copy of the data and restore everything from there. As a developer, how do you develop with the replica set? Well, I already mentioned, right, you're talking to MongoDB through a driver. So Python driver, Java driver, .NET driver, PHP, whatever language you use. The drivers understand replica sets. So if they connect to a replica set rather than a standalone node, the driver has smarts that keeps in touch with each member of a replica set. And this is so that if a primary fails, it'll immediately be polling who's the new primary, because it knows that it's sending all of the writes and all of the default reads to the primary. Now, there are actually multiple read preference modes. So by default, all the reads always go to the primary. Now, why is that? You'd think, hey, there's all these copies of the data, why wouldn't the reads just get spread around across all of them? Well, imagine that you want to have a strong consistency system. It's kind of what we expect of regular databases. If you write data, you should be able to immediately read it. If you write data and you go and try to read it from some other node, maybe that node is, got a lot of network latency and is falling behind, you might not be able to read your own writes. So by default, you will always be able to read your own writes. That makes it easier to reason about your application. Now, you can specify that you want the data to be read from a secondary node. For example, analytical applications probably don't want to read from a primary because they don't want to interfere performance-wise with the operational reads. Nearest is one that says, I don't care if I read from primary or secondary, I want to read from a node that's closest to me. And in replica sets, closest is defined by ping time. So it's a network cluster. Ping time determines how far away something is from me. So it doesn't matter if it's on the next rack. If it's got really slow ping to it, it may as well be halfway around the world, right? So if you request your reads from secondaries, you now have delayed consistency, or sometimes people call it eventual consistency. And I pretty much recommend against that for operational systems, unless you really understand the implications of what that means. Right? So if not operational systems, then who should read from secondaries? Well, you might have ETL job running nightly, right? That's pulling all the operational data to push it into your data warehouse or Hadoop or whatever, right? You might have ad hoc queries. What's the problem with ad hoc queries? Well, sometimes they don't hit an index because somebody comes up with a query that nobody had thought of before. What happens if you don't query a database through an index? table scan or collection scan, we call them in Mongo, right? So that pulls a lot of data into memory, and it affects your normal operational reads. So those are things you might want to isolate to a secondary. Any kind of historical reports. Historical reports are not sensitive to slightly stale data, unlike operational, where I go, why can't I see this? I just sent this, right? But if I'm looking at historical things, then obviously everything that I care about is going to be on all the secondaries already. Nearest is kind of special because if you are publishing and pushing a lot of content out throughout the world, you might want to use secondaries in a replica set to reduce the latency of making that read from wherever it is that the end user location of the application is. Right? So imagine that you have a requirement that any read must be fulfilled in 100 milliseconds total. If your user is halfway around the world and the latency to get to your primary is 75 milliseconds, that's 150 milliseconds just for the round trip. Doesn't matter how fast the database is, right? If you've used up your entire SLA on the network latency, you're not going to be able to return that read fast enough. So if your secondary is closer to where the application is or where the user is, that hit for the latency is taken only once, right? The data replicates. Now the data lives wherever that data center is, right? You have a data center in Europe, you have one in US, you have one in South America, you have one in different parts of Asia. If you're publishing the type of content, right, that is not very sensitive to being literally milliseconds behind, right, it's actually extremely effective to save on those network bills instead of having everybody go to one place to read the data, reading it from nearby. And of course, always use one of the secondaries for backups. And sometimes people say, but I have a replica set. Why do I need to have backups? Well, it's so that when somebody accidentally connects to the production system thinking that they're dealing with some test system and then they decide to drop something, so that you have a backup that you can go back to and then replay everything, which actually replication lets you do up to the moment that they did something bad. A more common scenario is somebody accidentally deploys an untested version of the software live and it starts kind of messing up data. And that's where backups really come in handy. Write concern. So another interesting feature of replica set is it lets you specify different write concern. So what's a write concern? So in MongoDB, when you send a write to the database, you get to specify when you want that write acknowledged. In other words, I send the write and I say, I want to know if that write is successful when it's applied in memory. That's the default, that's the acknowledged. Unacknowledged says, I'm sending you a write and I don't want to wait to find out if it's successfully written to the database. As long as it gets there, in other words, as long as there was no network error sending it to the database, that's unacknowledged. That's not very commonly, shouldn't be used very commonly, unless you have a lot of log data or things where each individual write is not super important. You only want to periodically check that the batches of them are getting in. But you can also specify for certain data, and because you can specify this on a per request basis, that you don't want to get acknowledgement until data has been replicated to at least one other node or to a majority of the cluster. The fourth one is journal acknowledgement, meaning when it's flushed to disk. I actually prefer replication acknowledged as being the most durable because, think about it this way, let's say that I'm a user, I create an account. You want to make sure that if you acknowledge to me, yep, your account's been created, that there's no situation when that data would be lost. Well, if you lose the primary, even if the data is on disk, it's not available, right? As an end user, I don't care that you still have that data committed to disk. I just care about the fact that I can't log in, even though I just created my account. So replication acknowledgement says the write is acknowledged as successful when the data has been written on the primary and at least one of the secondaries. So if the primary fails, one of the rules for the secondary election says you must be the most up to date to be eligible to be the new primary. So if I have a primary and two secondaries and one of them got the replicated the account creation, primary goes down, there's now an election the one who got the replication gets to be the new primary. The other guy is not eligible because he's not as caught up as the first one. So this is kind of a little visual representation, right? The driver sends something to the primary and says, acknowledge when you've written it, or acknowledge it when you've written it and you received acknowledgement from at least one secondary that it has written. And of course, write to the journal happens locally, but like I said, it's not actually as durable as making sure that something is replicated on another node in the cluster. So how does this work behind the curtains? By the way, I don't have a watch, so hopefully I'm not running too late. Started a little bit late. But some of the implementation details, which could be interesting if you've used MongoDB. It could also explain why I say replication can help if you're restoring systems after somebody did an oops. So the nodes are talking to each other every 2 seconds. There's a heartbeat between every pair of them. The heartbeat, among other things, although it's a very small packet, includes information about how up-to-date they are in terms of the applying operations to themselves. So every node generally knows if other nodes are behind or if they are down or unavailable. The replication is logical, not physical. And by that, what I mean is, if you execute a statement that has certain effect on the primary, what gets executed on the secondary is the equivalent of the same statement. So physically, it would not be guaranteed to have the same effect. In other words, the layout on disk could be completely different depending on, how recent the primary or the secondary have been, maybe resynced, right? One might be more compact than the other. One might have more fragmentation because it's been up longer. And it also means that if you have physical corruption on disk caused by, for example, a file system or a disk error, it's not going to be replicated on your other nodes, right? Which is kind of nice because, well, that's one of the things you're trying to protect yourself against with replication. So there's a database called local, and local holds everything that's not replicated that's special to the each node. One of the things, of course, is the configuration of the replica set. The other one is what we call an oplog. Oplog stands for operation log. So logically, every logical operation that happens goes into the oplog. The little green donut is supposed to represent that it's a circular buffer. It's a fixed size capped collection, meaning that when it's full, it just starts writing from the beginning. And capped collections have a kind of a cool attribute that the way that secondaries read them is they tail them. If any of you are Unix folks, you know how you can do tail -f of a file? And if there's nothing new in the file, it just stops. But when something new appears in the file, it starts showing it to you, kind of like if you're looking at a log file. So this is kind of how tailing the oplog works. Secondaries don't have to keep repolling. If they're caught up, they just wait, and as soon as something new shows up there, they get it. Oplog is also what we call idempotent. And what that means is if the same operation is applied to a secondary multiple times, it wouldn't have any different effect than if it was only applied once. And the reason that's important is, if a secondary gets disconnected, let's say a network fails, and it was in the process of applying something to itself, how does it know when it starts up if it actually applied that but didn't record it or didn't? Well, turns out it doesn't matter. It can start where it last left off for sure, apply the operations again, and they will not have any different effect. So insert says, okay, ID 1, value 1, and what goes into the oplog is operation is insert for such and such namespace, and the object that gets inserted is ID 1, value 1. So you can imagine if you did that 3 or 4 times, the effect would be the same, because the underscore ID is a primary key, it's unique, so you still only have one value. It's got, underscore ID 1 and value 1. What if it's an update? Now, if you've not used Mongo, this is a kind of JavaScript syntax that says that for every document that has underscore ID 1, which is going to match one document, increment the field called value by 10. So this is an atomic increment that allows you to, have counters that are tracking various statistics. Well, on the primary, when we apply this, the result of value will be 11. If we write this into the oplog in this format, What happens if inadvertently this operation gets applied more than once? We're going to increment something by 10 more than once, and that's very different than incrementing it only once. So instead, what we write to the op log is the equivalent of setting the value to what its final result should be. So the operation is update, and the object that matches O2 underscore ID1, the operation that it actually got was set the field value to 11. So if you run this twice, or 11 times, or 27 million times, at the end, it's still going to have the value 11, right? So oplog uses tricks like that to make sure that the application of the operation always has the correct effect at the end of the application of all of it. If you do a multi-update on the primary, for example, you specify multi-true to say every document should have a new field called name and its value should be foo. If 3 documents got updated, what goes into the oplog is actually 3, that's strange highlighting, is actually 3 entries, 1 for each individual document. So each entry in the oplog applies to 1 document. I would recommend that if you haven't tried it and you're curious about it, especially if you're already using Mongo, that you try it. The docs has a very simple, straightforward tutorial. You don't even have to have multiple machines. As you'll see if you come to my sharding workshop later this afternoon, I use my little laptop to run replica sets, sharded clusters. I'll frequently have half a dozen Mongo processes running on one machine. Just have to remember to give them all different ports. That's it. Anybody have any questions? If we have time. Do we have time? We don't have time. We started a little late. If you have any questions, find me at lunch and ask me there. Thank you very much.